Yes.
Crazy.
Please close the door. There are.
The seats are here.
There are other
The seats here.
Yes.
I'll only heckle you a bit.
Don't be shy. Come in front.
It's all over there.
Okay. Hello again. Welcome to this session. Now we have Alex Larsson, and he will tell us about Flatpak.
So actually, I'm going to talk about Flatpak as you would use it as an upstream maintainer of some program. Say you're a developer or maintainer, maybe the author or part of a team that maintains an app. What does Flatpak give you, and how would I use it? So first, what is Flatpak? How many have heard of Flatpak? So most people know what it is. It's basically an app system where you can install and run apps. That's like parallel to the regular way you install stuff. It has two major goals. It's cross-distribution and cross-distribution version. So you should be able to build a binary release of your thing and run it. Anyone should be able to run it, independent on what distribution they are on, and if they like update their host, the version of the distribution, or even like dual boot to another one, the things they installed should keep running. Not only should it keep running, it should be running these same kind of bits that you built and tested on your like CI system and like on your machine. So there should be some level of stability and quality in a particular build. Secondly, we want to support sandboxing. Sandboxing is a feature that requires some level of cooperation from the application. It also requires changes to the stack that like are work in progress. So sandboxing is an optional feature right now, and it will basically be forever. But the hope is that we will move towards more sandboxed stuff as time goes on, and then we fix app, we fix the platform, we fix the technologies involved. This talk is going to be not very much about Fedora or RHEL or Red Hat. It's about how you as an upstream developer who maybe are using some other distribution or have people from multiple distributions working on your app. There's also a talk later by Owen about how we can use Flatpak specifically to do Fedora stuff. But this is, I am an upstream, what's in it for me, basically. And I think this is a very important question that we have a poor answer to currently. Like, how do I, as a developer, release apps on Linux? Right now, you tag something in Git, you put a tarball somewhere, and you send a mail to some mailing lists, and maybe you pester some packages that you know of, and then you pray. Pray that eventually distributions will pick up your release. And it sometimes happens, sometimes it doesn't for good reasons. Maybe Debian is frozen, or maybe you're on a not rolling distro, so you never get any updates. Or maybe the package is just slow, or not working on it anymore. Basically, it's completely out of your control when your users get updates. The ridiculous part is that often you have some guy on the team doing the Windows build, and that is usually put up on the website the same day as the tarball. So the support on Windows is much better than on Linux. And it's really ridiculous. I mean, I know Tim, the Corebird maintainer, he gets complaints all the time about it's a Twitter client, so it doesn't support 280 characters since they raised the limit. But it does. Since the day they switched, he fixed it, and there was a quickly a release, but a release doesn't mean anything. People can't use it. And as things get more and more tied to web APIs or other apps that changed, or you just want to, update your look to match your website or whatever, there's no point where you're in control of what you ship. But with Flatpak, there is. And you can push a release and have it, your user could have it the day after. And if you have bugs, they will report it against the current release. I mean, it's probably the current stable release, not exactly the unstable you're working on, but at least it's not like 2 years old. So the hope is that we can like improve velocity in the whole ecosystem where you get a release out, people get new features, you get new bug reports back, and people get excited about the fact that they can give feedback and get a new release out. So hopefully it will generally improve the QA and stability and new features that we get. I try to sell Flatpak as a targeting desktop apps. A lot of people ask me, can I use it for server stuff or command line apps? And the technical answer is yes, you can use this for whatever, but there's nothing technically prohibiting you from running MongoDB in a Flatpak. It just doesn't make sense because the features that are specific to Flatpak are desktop integration. Like if you're using OpenGL, if you're using X or playing sound, it just automatically works. If you install an app, it automatically shows up in your environment, like your shell or KDE menus or whatever, which is not true for any of the other container-like systems. And on the other hand, the things that you would want from a server system is not there. Like we don't do any clustering, we don't do any automatic network hookup or firewalling or anything like that. And we fundamentally cannot because Flatpak is designed to be run as a user. There's no privileged part of it. And all these other things are fundamentally privileged operations that affect the state of the machine. So we can never set up firewalls. We can never change routing or anything. So if you're doing server stuff, you should be looking at Kubernetes, maybe Docker, OpenShift, these kinds of things. Command line apps are kind of a middle thing. It's perfectly fine to run command line apps in Flatpak, but it's a bit clunky how to start them. So depending on the type of app, like you wouldn't want to have a sed Flatpak because it's something you have in bash pipelines or whatever. But if you just want to start Midnight Commander, that works fine. So if you were to start packaging an app, there are certain differences in the runtime, like how the thing runs, that are different that you have to think about when you start packaging it. Basically, the apps are the same. You build it in a separate prefix. Every Flatpak app is built into /app instead of /user. But the rest of the code is basically the same. But there's still some issues that might hit you. First of all, the app doesn't run against whatever distributions you have installed. It runs against the runtime. And runtime is basically whatever that supplies /user in your application sandbox. And there are multiple runtimes available, and they are separately updated. So you pick one, and there can be multiple installed, and multiple installed app can use different runtimes at the same time. But if two apps share the same thing, they will both get updates when the runtime gets updated. So the runtime has the core stuff. It's somewhat like a minimal base image in Docker land, but not quite. It is read-only, whereas on in Docker you you add stuff to it, but with Flatpak you add things on the side, and also it's a living thing, so it gets updated in parallel to your app. Even if your app didn't update, you might still get a new libc with a security update or something. And it's not meant to be minimal. And it's not meant to be maximal either. It's like a trade-off where you try to put the most commonly used things in it. Whereas, you don't want to put everything because everyone has to be downloading this thing. And if it's things there that most apps don't use, that's extra download space. But if there's not enough there, then people have to bundle it themselves. Because whatever is not in the runtime, you have to bundle with your app. And bundle is a scary word, especially in distro circles. It's evil, and there's all sorts of problems with it. But it's fundamentally bundling that allows the disconnect from the host distribution. So it's fundamentally required. We try to work around some of the issues that bundling causes. The two major ones being bloat, because everyone bundles things, and security updates, because apps are now responsible to get security updates for whatever they bundle. The separation of the runtime and the app helps somewhat on both of these, actually. Like you can get separate updates in a shared way that all the apps automatically share. And the way we store stuff using OSTree, the deduplication that gives you helps somewhat with the bloat side. Like if two apps happen to bundle the same file, it will be shared in page cache and on disk and everything. But if you bundle two versions of the same library, but they're not quite the same, then you still get bloat. Third thing is that the app will eventually run in a sandbox. There is always some level of sandboxing. Like we have to use file system namespaces because otherwise we can't replace /user. So there's always be some things that could trip up your app. We always actually run in a PID namespace, so you can't really see other apps. And you can ask for permissions to other stuff, but by default, it's pretty tight. Another thing that's weird is that app name is important. Like you can install an RPM called foo.whatever, and it'd be the Firefox RPM that someone renamed. That wouldn't really affect anything other than possibly the RPM database. But for app names in Flatpak, we use them as a way to refer to the application ID in various persistent ways. So the app IDs are dbus or Java style, reverse DNS name plus whatever you want after that. And for instance, they're used for storing per app data. Since we, by default, are very sandboxed, we have a per app area where you can write stuff to. And if you don't ask for any other access, this is basically the only place where you have persistent write access. And we set all the magic environment variables, so most apps just pick that up automatically. But it's kind of a different way of looking at it than normally. Because these days, an app follows these global things and splat things out all over your home directory. But there's no way to separate apps then. Like the app can see the other app's files and modify them, and it's hard to delete an app and get rid of it's dropped all over the place. So it's kind of a change in how things are stored. I think it's for the better, but it's fundamentally required if we're ever going to have a true sandboxing. Another thing is that we don't splat files all over /user either. So various ways things work for integration doesn't work. Things like icons are in user share icons. And if your app is not installed in user, the shell will not find the icon. So we have a concept called exports. And an app is a bunch of files, and some subset of it is exported. And all the apps get exported to a common directory, which is made available to the shell. So things like icon, desktop file, debug service files, these are found by the shell looking in the specific directory. And all the files there are, during the export phase, we know about these file types. So they're sanitized. Like the desktop file has an exec, and you can put whatever shell in there, and it will run on the host when you click on this thing. And so we replace that with instead something that runs it inside a Flatpak sandbox, specific to your app then. And same with the debug service files also. And we limit what you can export in terms of custom MIME types and search providers. So, if you want to package your app, first of all, you have to pick a name. And as I said before, it's important to get this right the first time. It's kind of a pain to rename it, although it's possible. The point of the whole reverse DNS thing is to avoid accidental conflicts. So you start by using some domain name you control. Maybe you own escape.org, or maybe you're part of GNOME and you can use org.gnome, or you can use your GitHub user. They give you like org.github.username, I think. And anyway, you pick something that is controlled by you, so nobody else would randomly pick that. It doesn't just look like a dbus name, it is a dbus name. If your app uses dbus, you have to use the same thing. Like if your app already uses dbus, just use the dbus name as the app ID. Because these are tied together in the permission system and stuff. And therefore you must follow the dbus rules, which are most of the time sane. The only problematic is that dbus names doesn't allow underscore, or I mean dashes, so you have to use underscore instead, which is weird because the opposite is true of DNS names. But so if your DNS name is foo dash something, then you have foo underscore something as your dbus name. And the exported file names have to match this. They have to have the same prefix as your app ID. That way we guarantee that in the exports directory, like the shared thing, there will never be any conflicts of file names. And then you have to pick a runtime to run against. These are the most common ones. We ship them all on FlatHub. And if you're ever going to ship using FlatHub, you have to use a runtime that exists on FlatHub. We will maybe eventually add more there, but pick some of these. And the free desktop one is kind of like a default base that has X and OpenGL, and it has GTK3 even, and GStreamer. So it's pretty, it has SDL2. It's a great fit for games. But if... From Fedora or any distro? No, it's built from sources, basically. The base is from Jocto, although we're replacing that. But so the GNOME and the KDE platforms are for apps that actually use all those, and they generally follow the APIs. So there's a new major release every time GNOME makes a release and KDE makes a release. And if you're using Qt, then maybe you want to use the KDE one anyway, because you don't have to build Qt yourself. And the GNOME and the KDE ones are subsets of the free desktop one. They actually start from that one and add stuff to it. So a bunch of files in all of these, or actually most of them, are common, so they will be shared on the disk. So if you have the GNOME runtime installed and then install the KDE one, it doesn't make things a whole lot larger. It just adds the extra libraries that are specific to KDE.
Are you violating your naming convention on that?
For?
Rust.
Oh yeah, there's actually like the last element can have a dash in it. But that's not it's really complicated, and it caused a lot of pain actually at some point. So every runtime comes with an SDK, which is like a develop packages and RPMs. So it has the headers, the package config files, has the compiler, linker, make, GDB, strace. The what? I don't know. Yeah, so it has, and it's the thing you will build your app in, basically. And it comes with the basic set of tooling. There are some more uncommon tooling parts that exist as Sdk extensions. So if you're building a Rust app, we don't want to put the Rust compiler in there because it like revs every 6 weeks or something. So there's an extension point, and you can install the Sdk extension to get the Rust compiler in there, or Java, or Mono, or if you're a maintainer of some build system or something, it's also interesting for people to write these extensions. But then you start by writing a manifest file that describes your build. And Flatpaks can be built however you want. You can just untar, you can use uncompressed or RPM if you want. At the end of the day, it's just a bunch of files, but most people use the Flatpak builder tool, which is a high-level tool. It loads a JSON file, describes the build, builds from sources, basically a list of modules. Every module is kind of like a source RPM level. Does a bunch of sources, typically a tarball and some patches. And everything that's not in your runtime, you have to put in this then. So sometimes that's somewhat painful, but most of the time, everything you need, except for some very app-specific libraries, are there. So Flatpak Builder takes this JSON file, it looks at all the sources it needs, it downloads whichever it hasn't already downloaded, verifies the checksum, builds all the modules in order, and it's just really a tool that shells out to this lower level command called Flatpak build. If you want to, you could run that manually, but this is an easier way for things that are built in like traditional ways using AutoComp for CMake or things like that. Has some interesting features. It has a cache, a build cache, very similar to the Docker one, where Docker caches each layer. We do it after every module. We commit the current state, and then if you build again and you didn't change anything up to that state, we'll just use the latest cached thing. And we disable networking and all sorts of stuff during the builds. We also try to make the build, like the current working directory, a well-known thing that's all the same, even if you build on a different machine. So we get reproducible builds in terms of debug info and all that. And when you have the thing, you use run Flatpak builder. Appdir is just a directory where it will create to put all the things you installed to, and then a manifest. Optionally, you can pass in a repository, and then it will, at the end, export the final build to that repository.
Is it downloading distribution tarballs or Git repos? Like, where is it getting the source from?
On top of that, you specify the source that has URLs. It can be. It's never really RPMs, but it's like tarballs of sources or Git repos or things. If you manage to build something, you can use Flatpak builder -run to get a shell or whatever. At the end, there's so this starts a shell in the app sandbox, and then you can run it in GTB or directly or see if it works, experiment with it. When you're done, you can specify the repository. That will create an OS2 repository. You can add that to your local Flatpak installation and then install from it and run it. I mean, instead of this, you could also start it using the shell or whatever. And there's some specific stuff that we use -user to do per user install in the home directory, which is nice if you're doing like debug builds or something that shouldn't be system-wide and don't want to enter passwords all the time. There's also no GPG verify because I didn't sign the test build. If you actually are doing an official release, you should be passing a GPG sign to the build and then get an actual GPG sign repository. Here's an example, like minimal-ish JSON file. So it starts with the name of the app, the platform, SDK it uses, the like binary name that would be executed. It's a way to specify C flags and environment variables and stuff. It's a list of modules, a list of one. It's an automake style build, and here's the tarball, and this is the checksum. We just build that in the standard way. And then at the end, when everything's built, it applies something called the finish arcs. Like the final stage is Flatpak build finish, where you pass it a bunch of properties that you set basically on the metadata of the app. In this case, we want to have the X socket in there, and we want to have network access. So we share the network namespace. And then we remove all the shit that were produced by the build, but we don't want in the final binary. So in more details, these are the phases that Flatpak Builder goes through. And basically after every, or most of these, there's also a cache checkpoint. So we download all the sources, cache them locally in some directory. So if we already had it downloaded, that we wouldn't do that. We initialize the app directory so we can run basically we create it in the right way so we can run Flatpak build on it. And then we'll iterate over every module, create a temporary build directory, extract all the sources in it, build. In this case, it's an automake style build. But configure, make install. There's some extra things you can pass in, like config ops, make args, make install args, to do like tweaks what you want to build. And in the middle here, there's like a set of commands you can just give it, and it will run. If you are a different type of build system, it will basically switch out, configure for Meson or whatever. But they are essentially the same. And then you can specify some post-install commands. And then it will automatically extract the bug info from anything you built that wasn't stripped. And remove the builder and collect like a list of all the files that were installed or owned by this module. And it looks over everything, and then it does cleanups, which is basically a list of files and globs that gets deleted. Globs could be global like before, or we could have them per module. And per module, cleanups only affect files that were installed by that module. So you can say delete /bin in this module, and only the binaries from that module will get deleted. And then run finish and write a manifest file in the top directory so you can see what you built. And what we do is we resolve any stray references that aren't specific. Like if you have a build master from the Git repository, it switches it to the particular commit that you actually built against. And then if you specify the repository, it will export that. Most of the work is specifying all the modules. So these are things. Often they're easy, like automake stuff, GNOME and KDE release stuff. They're pretty easy. They're standardized ways to build. But some things are, old and crufty or weird. So sometimes it's a pain. But most of the time you just say, oh, this is a CMake thing, and it will just do the right thing. You set the configure options that you might need, disable this or enable that. There is a special type called simple, which doesn't really do anything except run the build commands. So which is great if you want to have a module that just installs a file, or if you're using some weird build system that we're not supporting. Yeah, you can affect things. Build options is interesting. You can set C flags, environment. Build args is actually passed on to Flatpak builds. You can affect the sandbox when you're building. The most common thing is to give a particular module access to the network. It's not something I recommend, but and definitely not allowed to build like that on FlatHub. But if you control the machine you build on, it's a simple way to build, some weird NPM thing that pulls in the world during the build or something. Blah, blah, blah. You can have recursive modules. A module can have modules in it, but that's just a fancy way of listing them that lets you structure things. And whenever you specify a module, you can also just have a string instead, and it would load that file as a snippet and insert it, basically. So if you want to share some module between different files, you can just put it in a separate file and include it. The source types are archive, Git, and Bazaar repository, plus these tweaks we have. It applies a patch, it puts in a file, creates a script from a set of shell commands, or you can just run some code in the setup phase. The most typical thing there would be have a sed thing that just seds the make file or something. And also you have to notice that everything is sandboxed, the build, but also the run. So you have to specify what kind of sandbox permissions your app eventually wants to have. And if you don't specify anything, you get like a really tight sandbox. that can't play sound, can't use any video, or the only thing you can do is you can connect to the system or to the session dbus, and you can own your own application ID as a name on the bus. That's why it has to be matched with the app ID. And you can't actually talk to anyone because there's like a filtering proxy in between you and the bus, but others can talk to you and you can reply to them, which is essential if you're using dbus for activations, for instance. Modern desktop file have like dbus activation method so that you start them by starting them via a dbus message. But anything above this has to be requested by adding it to the finish args. Here's some common commands. I'm not going to read them all. Most are pretty obvious. The file system have all sorts of things. You can also ask for read-only versions of things. And host means basically everything, and home is your home directory, or you can list specific directory or XDG, dir, user based things. And if you look at the man page for build finish, it's listing everything there. And you can also look at various already built apps at FlatHub, because there's some things are a bit painful to figure out how to give access to. Like we have this short snippet of stuff that you have to use to get access to dconf for your app, for instance. But these commands, or the switches, are also used for Flatpak run and Flatpak override. So you can give a specific instance of an app access, or additionally, every switch here has a reverse thing, like no socket equals x11, and will remove any access to x. So you can run an instance of your app with the particular permission removed or added. Or you can use Flatpak override to make that persistent. So every time you start the app, we add or remove permissions. If you start doing this, there are certain tricks you have to learn to debug stuff, to work with stuff. The -d command, or switch to run, gives you a devel environment where you're allowed to do ptrace and strace and GDB, plus it gives you all the tooling because it switches to the SDK instead of the runtime. And if you specify that command equals shell, you will get a shell in your app's sandbox. And then you can start a GDB or what have you to look at how it works or what ended up being installed and things like that. You can also run a platform directly or runtime, which is very nice if you want to look at what's in there or how does it work in some specific. Okay. It's also interesting that SDK is self-contained, so it's very easy to build cross-architecture stuff. Right? If your app can run, or if your computer can run the different architectures, like i36 on x86-64, you can just download the SDK and the runtime, and even if you don't have any 32-bit binaries installed, you can just build with -art and everything will work. And even more, if you install QEMU user static, that installs the bin format snippets for automatically running, say, ARM binaries using QEMU. So if you do that, and you download the ARM platform and SDK, then you can just run arch equals ARM, and it will cross-build the ARM thing for you. It's not fast, but likely faster than whatever ARM machine you have, because they're shit. Yeah.
That is super nice. Can we get more architectures there? Like AR64, I don't think is there.
Yeah, FlatHub has AR64 and ARM and until 32 and 64-bit.
And PPC64?
No, we don't have PPC yet, but we don't have a build machine for it.
Okay.
So if you give us some, we can add some.
But that kind of, if you want to run it on PPC64, you're kind of out of luck because you
Yeah.
don't have the runtime.
Do people
Yeah.
run desktops on?
I don't know. IBM does.
Yeah.
Apparently. I don't know why, but they do. So the other thing is FlatHub. Flatpak is fundamentally decentralized in that there's no built-in repository. You have to add one to even be able to install things, and all repositories they're equal players in the entire tooling, which is very important because I don't want to be tied to a particular person that distributes things. But it's also pretty painful for users and developers because everyone has to set up their own repository and everyone has to find all the repositories. So we created this thing called FlatHub, which is a centralized place for most Flatpaks. In particular, commonly used things and like free software stuff. It's similar to a distribution in that it contains one copy of every app, and it's meant to be the latest stable version. So there's no unstable stuff there. There's no nightlies. There's just the thing the upstream developer thinks you should run right now. And in fact, we allow and want the actual upstream to maintain and build their own thing on FlatHub. So the sources, and the sources, I mean the manifests and stuff, are stored in a repository under the FlatHub organization on GitHub. And if you add your app, we'll give you full access to that repository so you can build your thing whenever you want. So when you do a release, you just push the latest commit here, and it would auto-build everything. These are the arches we call them to build. If anyone has actual hardware, we can add to it. But right now, that's what we have. And if you look at the build, or like at the logs, like x64 is the only thing people actually use. And we have an instance of BuildBot that watches all the repositories. Whenever there's a commit to the master branch, it pulls it, builds it, signs it. If all the arch is built, we sign it and push it to the repository so everyone can download it immediately. We also have, or are working on a web front end for it. So you can go to this website, well, flathub.org basically. And you get a listing on it. We want to add search and stuff, but if you click on one of these, you get nice graphical. This is basically the app data, the same that GNOME Software shows you. We also integrate with GNOME Software and KDE Discover, so if you add FlatHub, your apps will be automatically available there. But like if you click on install, it should download a file that, if your MIME types are correctly set up and stuff, it should open in GNOME Software or KDE Discover and automatically install for you. Well, it's not visible here, but there's descriptions and the release information and how to install it from the command line and stuff. And you can browse between the screenshots and whatnot. We are pretty open about what we can put on FlatHub. You have to use one of the runtimes you already shipped. You have to have app data so we can have these nice graphical things. And you have to have the correct license. And we do support non-free software, but most of the times we do so via a feature of Flatpak called extra data, where we don't actually redistribute the binary part. We package like a wrapper build, and then on the client side, we download, so say Spotify, we include certain things that Spotify needs in our app, and then the client will download the Spotify binary from Spotify, and then they're combined at the end on your machine. Must be a stable release, must be reproducible, not fully reproducible, but at least not like build random branch that differs every day.
I was thinking, is there any support for doing extra data for sources that require authentication before downloading them?
It has been requested, and it's hard. It's hard to do because it requires interaction in the middle of download and stuff. But I understand where you come from. Like many things don't allow you to use, or they probably allow it, but they dislike it if you download stuff and didn't click through the web thing. Yeah, whatever. I think the correct way would be to have the EULA showing you the first thing you run the thing, but yeah. I don't know if that's good enough. It depends on the individual thing. We don't have any plans right now to add the feature, but we have had requests for it. We disable all the build args, so you can never use the network when you build stuff, which makes it somewhat painful to do things like npm. But we're working on tooling. We have a repository with Python stuff called Flatpak Builder Tools that has code for automatically generating include snippets for npm and pip. So you can do like, here's an npm log file, generate me the list of stuff this would download, and then I include that and it would auto download it. And then when you run npm, everything will resolve through the local cache, so it wouldn't actually download anything. And the way you get on FlatHub is kind of iffy right now, but basically you create a pull request against this FlatHub repository, and then people will look at it, queue a test build, give review, update the thing for feedback. Eventually people think it's all right, and then we'll create you a new repository and give you admin access to that. And then the build bot will auto pick that up and build it and push it. And whenever, like after that, you're a maintainer of the thing, and whenever you push something to it or accept a pull request, it will queue a new build. You can also ask us to force a build if there's some weird stuff going on. If you're using the pull request features of GitHub, you can actually type bot build in a comment, and it will queue a test build to see if the pull request works, which is kind of nice. Here's an example pull request for initial thing. Someone filed it, net queue the build. All checks passed. You can click on this thing, and it will give you information about all the builds. And click on here, you can get to the actual builds. If something failed, it will have red here and say this or that architecture failed. The build bot is really not quite meant for this. So the UI is sort of not great to navigate, but it has a list of all the stuff that's, well, currently nothing is happening, but this is the recent stuff. And if you drill down a bit, you can get a list of all the stuff that recently built. Some failed, some are greens. If you click on one of them, you can get a list, like information about the job build. In this case, all the arches built. So continue to update the repository and push the thing out. You can look at the changes tab to see what causes this to build. And if you look at the individual build, you get logs and stuff. Typically here would be the error if you have some kind of failure. I think we're sort of out of time, but there's a bunch of links if you want to start packaging your apps. And you can mail the list or me, or we hang out in Flatpak. Has Flatpak on Freenode if you want to talk to us. And I would love for people to add stuff to FlatHub. And also, we added some stuff to Flatpak. If we added your app, please come to us and take over maintenance of it.
Do you have a way to resolve that? Like if you have a Flatpak maintainer and the upstream project says actually we want to take over.
I mean, we want them to. Yeah. So we haven't had this good problem yet, but it would be good to have. The goal is that if there's a conflict, the upstream wins. But we also don't want to block on upstream if they're not interested. We'll just add the app for them.
Does OS 10 currently support file system namespaces and other
things?
No.
I actually tried to build Flatpak on Windows using the new Bash for Windows thing. But they don't support Fusey yet, and there was some other thing. Yeah, event FDs are not supported or something. But I think they're adding all sorts of stuff, so eventually it will probably run on Windows.
That would be really cool, because I can build, like, as an upstream developer, I could build one binary and have it run everywhere.
Yeah. Then all we need is a rootless Wayland compositor for Windows, and then you have like. That's good. Yeah, I mean, there are X1s already, so that would probably work too. But. Okay.
So the runtime has to kind of balance between being small and having all the stuff that you need. So, but right now it's kind of big. It's like 300 something megabytes or so.
Yeah, 200 meg, I think,
Yeah,
or
so,
250 or something.
So I built a very small application, and the application is like 5 megabytes, and there's 300 megabytes coming with it, which is kind of...
Well, hopefully you'll be using it for more apps,
Yeah, sure.
and those will be shared.
Anyways, the point is there any plan to make like make some sort of like the SDK add-ons, but for runtimes, so you can have, instead of having the full GNOME runtime, you could have like base GNOME runtime, and of course, if you go that way, then you end up creating RPMs all over again, right? But
Yeah, I mean, that's the thing. I want to avoid it becoming, because the second you start adding more than one thing and possibly an extension point, then the extension points themselves start depending on each other, then you're in like dependency hell again, because what version of that, and then maybe that was built against this version, but that was again, and it becomes really, really like RPM-ish, and I want to avoid that.
so it's going to be for the foreseeable future,
Yeah.
like a big fat runtime.
Yeah.
Okay.
And also, I think fundamentally, 300 megs is not that much. It just isn't these days for what it gives you. I mean, you're probably on your machine or running like 5 virtual machines, and so 300 megs is like half an audio CD or something. It's not much anymore.
Especially if you consider that it is meant for desktop.
Yeah.
So
Yeah, I mean, if it's an Internet of Things, super tiny thing, maybe it could matter. But if you download one movie, that's like got to be larger than all your apps together. So.
It's not like a blocker. It was just one.
No, yeah, no. I definitely do not want to reproduce RPM basically. Okay, one more.
Is there any solution for including proprietary codecs and all of the stuff we cannot include in any of the runtimes, for instance?
Well, I mean, your app is free to do whatever, right? But we have an actual extension point for FFmpeg. So the base runtime contains an FFmpeg that doesn't really have a lot of stuff in it. Well, it has like Ogg Vorbis and some other stuff. And then we have an extension that adds H.264 and AAC and some other stuff, which you can optionally install to automatically get those added, because the same API would be there. It's basically the same version of FFmpeg, but it has more stuff in it. And we also have extension points for GStreamer plugins where you can add stuff to it. But yeah.
Is it also possible to combine several extensions, or it just has to be just one?
So the extension points are either there is a single one, or there's a mode where you can have any number, but they get a subdirectory each. So it's like a subdirectory where there's a directory per extension. So that's what the GStreamer one would do. We also have an extension point for OpenGL drivers. So it auto-installs the NVIDIA. If you're running on an NVIDIA machine, it detects that and auto-installs the NVIDIA driver, and that will be picked up by the runtime.
does the GStreamer extension have enough metadata so that GNOME software could, like, for example, if there's a codec missing and GStreamer tells it that, let's say, MP4 is missing, does the extension have metadata? So
No, it doesn't currently, but then we could maybe add that.
It would be nice.
It's kind of, I mean, there's a risk of reproducing RPM, but yeah, it's interesting. Because right now you would have to know basically that if you install this thing. Now certain things are auto-installed, like we tried to figure out what OpenGL driver you're currently running at and auto-download that. So it will find if you're on NVIDIA and download that, but for these things it would have to be optional. So some kind of dependency, I guess, or recommends rather.
I generally love Flatpak because it's
sort doing a lot of things, but there's a simple problem. You mentioned in your presentation, for example, this Inkscape, which in general works great, but if you have a system where you don't have icons for this app, there will be no icons. In the case of Inkscape, it's like that.
Okay.
I don't know if it is a technical limitation that it tries to adapt your current theme or icons.
Oh, maybe it picks up the icon theme
so
or something.
If you don't have icons for this new app,
Yeah.
there will be no icons.
That's kind of, I mean, did you try this recently? Because we actually...
I have a really last version of Inkscape now.
Yeah, but semi-recently we added support in Flatpak for actually exposing icons. Because those are basically safe to expose, right? So
is it possible that I have an older version of Flatpak itself?
Yeah.
That's the first thing. And second thing, I then installed those icons. So
Yeah.
maybe it's now fixed and I can see it because it's working anyway.
Yeah.
So
yeah, theming is complicated. We have some stuff are available as extension points. So we have themes, GTK3 themes, icon themes on FlatHub. We try, or we want to at least make it auto-install those. I think we currently do that, but we want to eventually make software auto-install matching themes. But some things like GTK2 themes are libraries that run in the same, so they have to be linked against exactly what's in the app, right? And that's hard to do generically, so we don't support those. All right, last question.
Where can I get such a t-shirt?
Alan, I bought it at Aquatic. I think Alan has a bunch of them. Okay. I don't think we have any of them here.
I have a real question. What's next?
What's next? I plan on getting some kind of stable 1.0 release out this year. Focus currently is on making the breakout of sandbox model more fleshed out. So we have support for something called portals as a way to safely break out of the sandbox and make that realistically useful so that a larger amount of apps can work sandboxed. And then there's like planned work on making FlatHub more useful, nicer, have more apps. All right. I guess I'm done then. Thank you.
I would like to remind you to leave a feedback for this session on sketch.org. And at 17:15, there will be a small surprise in the venue, so be there.